Hello and good afternoon my dear kids. Welcome back once again to this short tutorial video for class 7 students. And as you know that we have just started the basics of geometry. So in this video too we will be discussing few more basic terms of the geometry. Okay, so that is what I have given the topic name as lines and angles continued. So since we are doing lines and angles, isn't it? So in this one, and as we have already discussed in the previous video that how an angle is formed and all, isn't it? For those who haven't gone through the previous video, please go through the previous video because you will be missing the important terms from the basics. Okay, and in this one, that is for types of angles, I have given the page number as well of your textbook. Okay, so if you find it difficult to look at the words and all in the video, so that you may be able to rectify your spellings and all from your book as well. Okay, so okay, what we have here is types of angles. So since in the last video I have told you how an angle is formed, so here we'll be dealing with types of angles and all. Okay, so types of angles, the first angle that I have taken for today is an acute angle. So an acute angle, as we have already discussed on the previous video that how an angle is formed and how it is measured in degrees and all, isn't it? So say an acute angle, an angle whose magnitude or measure is same thing. Okay, an angle whose magnitude is greater than 0 degree but less than 90 degree. An angle whose magnitude is greater than 0 degree but less than 90 degree is called an acute angle. Okay, that means an acute angle will be greater than 0 degree but less than 90 degree. Any angle which is greater than 0, less than 90 is known as acute angle. Like something simple examples are, you can just simply say 20. Yeah, 20 is an acute angle because it's greater than 0 but less than 90, isn't it? Whichever number comes greater than 0, less than 90 is known as your acute angle. Okay, whichever measure, whatever measure comes of your angle which is greater than 0 but less than 90 is known as your acute angle. Okay, now the next one we have here is right angle. An angle whose measure is 90 degree. An angle whose measure is exactly 90 degree is known as right angle. Okay, it's just not more than 90, not less than 90, it is exactly 90 is known as your right angle. The third type of angle we have here is obtuse angle. So for an obtuse angle, an angle whose measure is greater than 90 degree, is greater than 90 degree but less than 180 degree. Okay, an angle whose measure is greater than 90 degree but less than 180 degree is known as your obtuse angle. So greater than 90 means yes, 91. If you call 91 an angle, then 91 is also an obtuse angle. And if you call 179 also, then 179 will also be your obtuse angle. Okay, just the criteria is that the angle has to be greater than 90 and less than 180 degree to become an obtuse angle. Okay, the fourth one here is straight angle. An angle whose measure is exactly 180 degree. Now see again, for 90 degree it's a right angle triangle, a right angle. For 180 degree, an angle whose measure is exactly 180 degree. 180 degree is known as a straight angle. Okay, not more than 180 degree, not less than 180. Angle whose measure is exactly 180 degree is known as your straight angle. Now after that comes a reflex angle. Say for reflex angle, an angle whose measure is greater than 180 degree. Again, greater than 180 degree but less than 360 degree. Greater than 180 degree but less than 360 degree is known as your reflex angle. Okay, and after that comes a complete angle, and an angle whose measure is 360 degree, exactly 360 is known as your complete angle. Actually your complete angle is nothing but a circle. Okay, a circle is a complete angle, that is its measure is 360 degree. Okay, so for acute angle, see I have drawn figure out here. Now see acute angle, it can be see you might get confused because see why I have drawn both the sides the figure, why I have drawn two figures is like mirror image of the figures is because see when your the baseline, this one is actually the base. Okay, and this is your the measuring line actually of the angle. Okay, when your baseline is towards right, and that point we have to measure the angle. This direction is known as anti-clockwise. This second hand of the clock rotates this direction, in this direction, isn't it? This direction. So if you go with the opposite direction for that, it's known as anti-clockwise direction, isn't it? Now that is only when, remember, the base arm, we can call it as arm as well, isn't it? From the angle section I have discussed that in the angle section as well. The arm, suppose the arm is moving towards right, and at that time you have to measure the angle anti-clockwise, in the anti-clockwise direction. Okay, in the anti-clockwise direction, then this will be your acute angle. Okay, try and see in your protector as well. Okay, in your protector you might get when you moving towards the right, you will be getting a 0. You will be getting a 0 as well as 180 degree in your protector. But when taking your arm towards right side, you have to measure from 0 degree. So 0 degree towards in the anti-clockwise direction, that will be your measure of the angle. So that will be your acute angle, because it is less than 90 degree. 90 degree is a straight arm. It will be, the another arm will be very straight to the base arm. Okay, similarly, now the other way around, when your arm, the base arm, remember, when your base arm of the angle is towards left, and at that time the clockwise direction will be your measure of the angle. Okay, like for example, here also in your protector you will get 0 and 180 degree, and at that time you have to start with 0. Okay, so when your arm, base arm is towards left, clockwise direction, when your base arm is towards right, at that time anti-clockwise direction. Okay, to measure the angle. Okay, so later on you will get to see, you will be just directly looking at the angles, and you may figure out which one is acute, which one is obtuse, and so on. Okay, so see, why I've shown you this two is because, see, after that what do I see is right angle. For right angle, see, suppose, as I've already said, towards left, towards right, this first point will be 0. Now see, from 0 to 90, it's a right angle. See, 0 to 90, and it's denoted with this symbol. A right angle is always denoted with this symbol, remember. Okay, so as I've already said, there will be two, and see, the two lines will be perpendicular. It's also known as perpendicular lines. Okay, perpendicular lines, so it will be straight towards one another. Okay, not straight, they will be intersecting, but see, the lines will be straight. Okay, so see, obviously if this, from this point to this point is 90, that means, see, obviously if from here to here it's 90, that means it's increasing, isn't it? Anti-clockwise direction, it's increasing. So, but in the first case we have stopped somewhere in the middle. That means it's below 90, isn't it? So obviously that means it's an acute angle, below 90 but greater than 0. See? Okay. Similarly, when your base arm is towards left, similarly, see, this one is 90, as I've already said. For 98, you will get two perpendicular lines, two straight lines, intersecting lines, or you can call it bisecting or intersecting also. Okay, the terms, don't worry about the terms, you'll get to know about the intersection and bisection as well. Okay, intersecting and bisecting lines as well. So see, this is the sign, symbol for 90 degrees, I've already said. So similarly here as well, the clockwise direction, see, the clockwise direction from 0 to 90, it's moving, for 90, it's stopped here. Similarly, if I compare these two, obviously then it's less than 90 degree, isn't it? See, the arm is towards left. See, the arrow is towards left, and we are going from 0 to 90. Here 90 is this straight, but this one is little bit less than 90, isn't it? So obviously it is less than 90 but greater than 0. So that is why it's an acute. See, it's a right angle. Okay, I hope you can figure out the difference now. Okay, now see, that is why we have written for 90 angle, the measure is exactly 190 degree. The measure is 90 degree, isn't it? Now see, for obtuse angle, yes, what we have written for obtuse angle, an angle whose measure is greater than 90 degree but less than 180 degree. Now see again, when you are going towards, see, the base arm is towards right. The base arm is towards right. What happens when base arm is towards right? We'll measure the angle in anti-clockwise direction, isn't it? So see, it's increasing, and it has crossed 90, because 90, there will be a straight line for 90, isn't it? So it has exceeded 90 and crossed 90. So see, that is what we have written in the definition for obtuse angle, when the measure of the angle is greater than 90 degree but less than 180 degree. So it's obviously greater than 90. So that is why it's known as obtuse angle. Similarly, when the arm is towards left, see, when the arm is towards left, so At that time, what happens? We will measure the angle in clockwise direction, isn't it? So for clockwise, when measuring in clockwise direction as well, we know that on straight line, when we'll get two perpendicular lines, at that time it will be 90 degrees. So see, obviously you can figure out from here. See, is up to here, suppose it's 90, and this direction is increasing, and then obviously it will bypass 90. It's obviously greater than 90, isn't it? So it is an obtuse angle. Okay, and after that comes a straight angle. See, for straight angle, it will be like a straight line. Okay, so simple. Here is the end point of two rays. This one is also known as vertex. Suppose if you make this as point A and point B and this O as your vertex, then a straight line will be known as your straight angle as well. Okay, and then a straight angle, the measure of straight angle is 180 degree. That means for a straight line, obviously in straight line and in straight angle, they are same things. Okay, the measure will be equal, that is 180 degree. Okay, it's just that in case of a straight angle, there will be two rays, involvement of two rays. Remember, involvement of two rays with a common end point, and there will be vertex as well. Okay, the figure may look similar. See, for straight line and straight angle, you may look at the figure. They may look similar, but they are not actually. Okay, though they measure and their measurement is also equal. Okay, now for reflex angle. See, for reflex angle again, the base. See, the base angle, the base arm, not the angle, the base arm is towards right. So what did I say? Towards right. For towards right, we need to go for anti-clockwise direction, isn't it? So we know from here to if we measure a straight for perpendicular line, here it will be perpendicular, it will be up to 90. So from here up to this line, straight line, it will be 180 degree. So it's greater than 180 degree. Obviously, see where the angle is going. Angle is going in this direction. The measurement, isn't it, in the anti-clockwise direction? So anti-clockwise direction, it has crossed 90 as well as it has crossed 180 degrees. See, so that is why we have written for reflex angle, the definition we have written as when the measurement of angle is greater than 180 degree but less than 360 degree, at that time it is reflex angle. Similarly, see, when we take the base arm towards left, then at that time I said clockwise direction is for measuring the angle. So for clockwise direction as well, see, from here to here up to when a perpendicular, for up to perpendicular line, it will be 90 degree, isn't it? So from up to here it will be for straight line 180 degree, and up to here is greater than 180 degree obviously. So it's a reflex angle. Okay, reflex angle greater than 180 degree but less than 360 degree. Okay, so and as I've said, for complete angle, it's actually a straight circle. So a complete angle means a circle. Okay, now okay, after that comes an adjacent angles. Now see, for adjacent angles, two angles with a common vertex and a common arm forms a pair of adjacent angles. Now see, two angles with a common vertex and a common arm forms a pair of adjacent angles. So what does actually adjacent angles mean? When two angles, they have common vertex and they got common arm. So what is it actually an arm? An arm of an angle is actually the ray, isn't it? So see, how many rays do we have here? See, OA, one ray, OC, another, OB, another. That means actually in this figure we got three rays, isn't it? OA, OB and OC. But all the three rays, they share a common endpoint. See, common endpoint O. That means obviously the angle will form there, isn't it? So see, this angle that is formed here, the angles formed here are, see, actually AOC, or the angles formed COB, another angle. There is one other angle also, see, AOB. Now AOB is a straight angle actually, isn't it? Isn't it? So AOB is your straight angle. Now see, in the above case as well, in the above of AB, above also the above the line also we got a straight line, straight angle, isn't it? The straight angle has been divided into two angles. That is, see, with OC as common arm. So in that case, your angle AOC and COB is known as your adjacent angles. Okay, with OC as your common arm for both the angles. Now at this point, these two angles, they are also known as linear pair. Remember, these two angles, they are also known as linear pair. Now remember the terms as well, because I'll be telling you about linear pair as well after a few topics as well. Okay, these two are also known as linear pair, because in this one, what has happened is the straight angle has been divided into two angles. At that time, it's known as linear pair as well. Okay, and why I have marked with one line, one arc and two arcs in here is because these two angles, they are different. Obviously, AOC is an obtuse angle now. See, because see, what do we see here is AOC. When looking at AOC angle, the arm, one of the arms of the angles is towards left. So what did I say? When one of the arms will be towards left, we have to measure the angle anti-clockwise direction, clockwise direction, isn't it? Clockwise direction. So clockwise direction, see, clockwise direction, the straight perpendicular line will be your 90, so it is greater than 90. So see, obviously, what you can see from the figure is that AOC is an obtuse angle as well. See, similarly, COB, I can call it as acute angle. Why acute angle? Because OB, when you just look at COB, just hide this one. Okay, hide the ray OA, and what do you see is COB. For COB, OB is towards right, and for towards right, what did I say? You have to measure the angle in anti-clockwise direction. So see, for anti-clockwise direction, when you are measuring, so I know that a perpendicular line will be here. Up to there it will be 90. So it is obviously less than 90. So it's an acute angle. See, that is why I said the figure will tell you about their special types as well. Okay. Okay. So now the next topic for here is today is complementary angles. Now see, for complementary angles, these are easy ones. Okay. Two angles whose sum is 90 degree are called complementary angles. Simple. When you add two angles and their sum comes up to 90 degree, then those two angles will be known as your complementary angle. So simple examples are an angle with 60 degree measurement and 30 degree measurement. 60 plus 30, it's 90, isn't it? An angle with 45 degree measurement and 45 degree measurement. When you add those two, you will get 90, isn't it? So those two angles will also be known as complementary angles. An angle with 70 and with 20, when you add them, you will get 90. So complementary, simple. An angle with 1 degree measurement and 89 degree measurement will also be known as your complementary angle, because 1 plus 89 is 90, isn't it? Okay, a simple one. So similarly for supplementary angles, two angles whose sum is 180 degree are called supplementary angles. So simple, both the angles, remember, when both the angles are kept together whose sum is 180 degree, that time they are known as supplementary. Similar like complementary. Complementary means 90, supplementary means 180 degree. Okay, so a few big examples I have given here, 120 and 60. When you add them, you will get 180 degree. 90 and 90, 180 degree, isn't it? 180, 180 degree. Okay. Okay. Now this one is also very important one. Okay. Now see, vertically opposite angles. For vertically opposite angles, two lines when they intersect. Now see, what did I told you about the terms? I told you that I'll come to the point as well, isn't it? Two lines when intersect. See, intersect means just they are crossing one another. Okay. Two lines when they intersect, they form four pair of angles. So see, what do I see here is AC one of the lines, BD one of the lines, isn't it? Two straight lines. When two lines are intersecting, what happened is they have intersected through a point O. See, they have crossed through a point O. Now at that time what happens is they form four pair of angles. So this is what they have formed. See, now see, if I mark the point of intersection as O, now what do I see here is COB, one of the angles. See, if I consider OC as one of the rays and OB as one of the rays, then I have got one angle, isn't it? Similarly, DOC, one of the angles, DOA, one of the angles, and AOB, one of the angles. See, so that is what I have written. Two angles, when they intersect, they form four pairs of angles. Each pair of opposite angles are equal and they are known as vertically opposite angles. Each pair of opposite angles. So that is why I have marked here with C. Each pair of opposite angles are equal. Remember, opposite angles are equal and they are known as vertically opposite, isn't it? So what is opposite for AOB? Which is the opposite angle of AOB? Obviously DOC. So that is why I have marked with two arcs. See, as I have said, the symbol plays a very important role in geometry. So that is why, see, for these two lines, two arcs on the angle means these and these angle, these two angles are equal, and these two angles are equal with one arc, one arc. See, it's because they are opposite angles, isn't it? So that is what we have learned from here. Two lines when intersect, they form four pairs of angles, and each pair of opposite angles, they are equal and they are known as vertically opposite angles. Okay. Now the another topic we have here is bisector of an angle. See, a line that divides an angle into two equal halves is called the bisector of an angle. So simple, and bisector of an angle means nothing but when a line or say for example in this one, suppose for AOB, now you can figure out that AOB is a acute angle, isn't it? Now what I have drawn here in this figure is angle. I have divided angle AOB into two equal angles. See, that is why I have drawn with one arc and one arc. Now which is dividing the angle AOB? The bigger angle OC is dividing. Now this OC has divided the angle AOB into two equal halves, that is AOC and COB, isn't it? Now these two angles I have made equal. Now which has divided? The ray OC has divided. At that time this ray OC is known as the bisector of the angle. Okay, why bisector? Because it has divided the bigger angle AOB into two equal halves. You can simply say that angle AOB, suppose if angle AOB is 60 degree, then it has been divided into 30 degree and 30 degree by OC. So therefore OC is known as the bisector of the angle. Okay. So the last topic for today we have here is a linear pair. Now see, again I said about linear pair few minutes before as well, isn't it? Now see, and see, there comes adjacent angles, the term adjacent angles also. Adjacent angles which lie on the straight line form a linear pair. See, adjacent angles which lie on the straight line, they form a linear pair. What did I say about adjacent angles? They will lie on a sometimes they may lie or sometimes they may not lie on a straight line. Okay, but when they lie on a straight line, adjacent angles, the pair form a linear pair. That means what we know? We know that the straight line, the measure of the straight line is 180 degree, isn't it? So here what we have, see, AOB a straight line, and we got OC a common arm for angle AOC, and COB, OC a common arm. Now these two angles, they are adjacent angles, isn't it? But see, I have drawn here one arc, two arc. That means these two angles are not equal angles. That is what you can just look at the figure and predict as well, because AOC is an obtuse angle, BOC is an acute angle, isn't it? So how can they be equal, isn't it? Obtuse and acute. So but when we add these two and they form the total, they will give up to 180 degree. In that time those two angles, they are also known as linear pair. Okay, so I hope you kids have understood the basic terms from the geometry section, and please, if you haven't, then please go through the video once or twice or as much as you can. Okay, because while doing the sums we'll be just taking the terms and we'll be proceeding towards the sums. Okay, so, and similarly for this video, from this video also, all the topics I want you to write down in your copies as well. Okay, so till then, stay safe and stay tuned in for more updates. Okay, bye bye.